we are on the page that doesn't have a page number. Says the very first page says business calculus is the topper, applications of business, profit, revenue, and cost with quadratics. But we'll look at number 4. Okay, so number 4 says, suppose that a company has a fixed cost of $28,000 and a variable cost per unit of 2/5 X plus $222, where X is the total number of units produced and suppose further that the selling price of the product is $12.50 minus 3/5 X per unit. Find the break-even points. Okay, so break-even points, what I can do is just jump on Desmos, hopefully, today. All right, so I'm just going to graph the two things that we know. Y equals 2/5. I know it doesn't say Y equals, but we'll just throw Y equals in there. So we have Y equals 2 divided by 5 X plus 222. And then we have the Y equals 1250 minus 3/5 X. Okay, so that's all fine and dandy if we try and graph that. But if we start zooming out, we find that. But we also have something else to this problem that we have to look at. Suppose a company has fixed cost of $28,000. The variable cost per unit is 2/5 X plus $222, where X is the total number of units produced. Suppose further selling price of the product is $12.50 minus 3/5 X dollars per unit. So technically, this is the break-even point that we have right at this moment. But what should we do with the 28,000? Or is it just extra information as far as the problem goes? What do you think? Yeah.
Can you graph the point and see where?
Right. I like your thought. So I'm gonna graph two different ways of thinking about this 28,000. So I'm gonna go Y equals 28,000, which would be a horizontal line. That's 280,000. And then I'm gonna do X equals 28,000. Okay. So notice we got to go way out here. Okay. So theoretically, I guess if we looked at Y equals this scenario, the red line was the cost. So that 28,000 at that outside juncture and the green versus the red line, that just basically means that you're at 69,445 units to get to that region. Now, how do we know that we're not looking at the X equals 28,000? And the answer is, well, can we investigate a little bit further? It says, suppose the company has fixed cost, bless you, of $28,000, a variable cost per unit of 2/5 X plus $222, where X is the total number of units produced. So because X is the total numbers of units produced, the X value is the units produced, the Y value is the cost, so that means that I don't need the purple equation. Okay, the purple equation was extra to put in there. I wasn't quite sure, but by further investigating, I realized the money value is the Y equals component. Okay, so if I were to sell 69,445 units, I'm at pretty much my maximum that I could produce. I'm getting to that 28,000. Now, if I come in a little closer, I can still get this point here, and then I can get my break-even point here. Okay, so the break-even point is at where the blue line and the red line intersect each other. So if I produce 1,028 units, then it's $633.20. That's our break-even point. But the maximum amount of units that I can create is 69,445 because I don't have enough money to produce more than that. Hopefully, once I sell those 69,445 items, I make profit, and then I can maybe make more of these items in the future. So for the profit function, so this is going to be my maximum profit. So if I create 69,445 items, my maximum I'm going to make in this is 28,000. I can't go beyond it. I'm bounded. I'm limited by the amount of money I have. Just because you have a machine that's producing items, it doesn't mean it's going to make infinite items for you. You're limited by time, you're limited by space, you're limited by money. So that's basically taking care with that. There's other questions that are in there, but I think we've hit the most important things so far. So just kind of note that when you have that extra value in there, take a look. Is it a money value or is it an item value? If it's a money value, it's more likely going to be a y equals. If it's an item number maximum, then it's going to be an x equals. Does that make sense? All right, use a previous example. We don't have to worry about that. All right, flip the page. So now I'm on worksheet 2.3. Have we done anything on 2.3? Have I signed that? Okay. I had last year's book, so I saw that something was assigned last year. But it doesn't make sense to me, the date that I have on it, so I don't know what I was writing. All right. So first thing we can do, because we're using Desmos, we don't have to worry about the 0 to 25 and the 0 to 100 in the XY direction. Desmos is going to do it just fine. The reason we had that is on the TI graphing calculators. You could zoom in and zoom out, and you're like, well, what size window should I use? That was just telling you which unit to use. Okay? The supply function, whose equation is... All right, so let's get rid of these. Well, hey, how you doing, sunshine?
I'm doing pretty good.
Yeah, baby. Sorry to call you sunshine, but it sounded funny at the time.
It's all good.
We're on page 2.3. All right, so again, I don't have to worry about it. So sketch to the first quadrant. Well, yeah, first quadrant just means this quadrant here is where we're sketching. And so I can zoom in, make it a little nicer to deal with. Okay, because quadrant 1, you're obviously not making negative items. Okay, so you have this equation. So the p-value is going to be your y equals. So let me just go out on the screen real quick. If I have this, this is p, which is equal to our y value. This is q, which is equal to our x value. Okay, this is quadrant 1 for those of you who have taken beyond Algebra 2. Okay, did you ever know why the Cartesian plane, the xy axis, did your teachers ever tell you why it's numbered this way? Anybody know? It's the most non-mathematical answer in the world. Descartes, looks like Descartes, who was a mathematician, created the Cartesian plane. He was left-handed. It was easier for him to do left-handed that way than this way. That way he didn't get the ink on his hand when he went this way. That's the only reason it's labeled 1, 2, 3, 4 in that fashion. I mean, I've come across math teachers and say, hey, why is it labeled that? Oh, well, that's why it was. It's like, no, Descartes, who designed the XY axis, was left-handed. Left-handed people makes it easier so he doesn't get ink on his hands, because back then they used, a feather quill and ink. So if he wrote the 1, and then he went to the left and wrote 2, then he went down and wrote 3, I guess 3 would have gotten on his hand to write 4, but that was the main reason for it. He was left-handed. So, but anyhow, we're in quadrant 1, which is this quadrant that we'll be dealing with on Desmos, okay? So it says supply function is P equals, so I have Y equals 1/4 x squared plus 10. And my graph is goofy, so you can always hit home and then kind of refine it. So we have ourselves a parabola. Yay. The demand function is P equals 86 minus 6Q minus 3Q squared. So we're going to plug our p-value is y equals 86 minus 6x minus 3x squared. So, cool. This is the value that's in quadrant 1. This is in quadrant 2. Am I producing a negative amount of things? So the negative 5.846, comma 18.544, that's irrelevant. So circle and label equilibrium point. This is my equilibrium point right here. That point that I'm kind of circling. Use the space to algebraically determine the equilibrium point. I use Desmos, 4 comma 14. You don't have to do anything beyond that. Okay? Yeah, I guess you could have set them equal to each other, went and used a whole bunch of algebra to solve it, and you would still come out to the exact same answer. And I like Desmos better because it's clean, it looks nice, it's fancy. So, those are the things that you are going to work on for tomorrow. So same idea. Just realize that the p-value is going to be your y value, the q value is going to be your x value. So I would bet you would probably feel comfortable working on the worksheet 2.3. And if you do 2 through 5, because we already did 1. Did you guys know that teachers are hypocrites?